So dear students, in this video we are going to study combination of capacitors, which will be of course parallel plate capacitors in circuits. So this topic is specially based on like how we can put more than one capacitors in circuits, how we can combine more than one capacitors in circuits. So first one is series combination. First one is series combination. So in series combination, two capacitors of capacitances C1 and C2 are placed in series. Okay. Now, since in series combination, same amount of current I flows through the both capacitors. Same amount of current I flows through the two capacitors. That means charge stored in each of the capacitor will be same, because same amount of current is flowing through the capacitor. So what is okay, since charge is same in two capacitors, but one thing will be different in two capacitors, that is the potential difference. So potential difference between the two capacitors will be different because they have different value of the capacitances. Now let this combination of series is replaced by a resultant capacitor. These two capacitors are replaced by a resultant capacitor of capacitance C. But again in this resultant capacitor, what thing will remains the same? Charge Q will remains the same because these two capacitors are in series. So individually they store the same amount of charge equal, like individually also. So if the charge stored is Q, here also the charge stored will be Q because they are in series. But what thing will vary? The potential difference on this particular resultant capacitor will be different, and this potential difference V will be simply the sum of the individual potential differences of the two capacitors. So this V is equals to, we know Q is equals to C is equals to Q by V. So V will be equals to Q by C from our formula of capacitances. So V is equals to Q by C. So this V will be equals to Q divided by C, and this V1 will be equals to Q divided by C1, and this V2 will be Q divided by C2. Q divided by C2. So Q cancels. So 1 by C will be equals to 1 by C1 plus 1 by C2. So if two capacitors are placed in series with one another, then the resultant value of the capacitor, the resultant value of the capacitance will be simply 1 by C1 plus 1 by C2. 1 by C is equals to 1 by C1 plus 1. So the resultant will add up like this. If there were n number of capacitors, if there were n number of capacitors in series, then the resultant capacitance of the capacitor will be 1 by Cn will be equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by Cn. So the resultant capacitance of the capacitor will add up like this. Now the second combination of capacitors are parallel combination. Parallel combination where two capacitors of capacitance C1 and C2, two capacitors of capacitances C1 and C2 will connected like this. So this is parallel combination where two capacitors of capacitances C1 and C2 are combined in parallel combination. Now since they are in parallel, so different amount of current flows through each of the capacitor. So I1 current flows through this capacitor and I2 current flow through this capacitor. Now since different current flows through different two capacitors, their charge stored will be different. Their charge stored will be different. Here Q1 amount of charge will be stored, here Q2 amount of charge will be stored. But what thing will remains the same? The potential difference between the plates will remains the same because they are in parallel combination. Now if this combination of capacitors is replaced by a single capacitor of capacitance C, then what things will remains the same? The potential difference will remains the same because individually also they have V potential. Now if they are replaced with single capacitance of C, then also the potential difference will remain the same. But what the things will change? The charge stored will be different. Okay, because they are in parallel. Now the charge stored in this Q capacitor, like this resultant capacitor, will simply be the sum of the charge stored in this individual capacitor. So Q will be equals to Q1 plus Q2. Now Q is simply C by V. This Q is C by V, and this Q1 will be C1 by V, and this Q2 will be C2 by V. Q2 will be C2 by V. So what things will cancel? V will cancel. So C will be equals to C1 plus C2. So when two capacitors are combined in parallel, then their capacitance will add up like this. So such that the resultant capacitance will be C is equals to C1 plus C2. Now if there were n number of capacitances or capacitor, then the resultant capacitance will be C1 plus C2 plus C3 plus C4 plus up to Cn. So this is the resultant capacitance of the capacitors placed in series. Placed in parallel combination. So this much for today. Thank you.